Okay, let's keep going. So the last of this chapter, we're going to talk a little bit of statistics. If you really want to know statistics, you need to take the class. It's a one semester class. So here we briefly talk about a few factors. Like how do you use statistics to explain your results? We always try to explain the results, right? Let's do an experiment. Okay, I give you two puppies. I'll ask you how cute do you think this puppy is? From 1 to 5. Most of you, okay, you can vote. You will say 4, 5, and the whole class. I have 30 votes. And most of them gonna go to 4 or 5, right? And then I will give you this picture, ask you how cute this puppy is. You say this is a puppy. Okay, well, every puppy is cute, but if I ask you how cute this puppy is, you may go to a 3 or 2. Right? So the most class will give me a 3 or 2. Okay, now I have two sample. I have two group of number. Just one example. And how do you analyze this data? How do you say this puppy is cuter than this one? Even though I should not say that. Every puppy is cute. Just one example. Sorry if I offend you. We do have people think this puppy is cuter. Yes, it's cute in a certain way. Just say in general. One thing you can do is the mode. Like these two pictures, okay? The first puppies, the most frequent number, this is the mode. This is the mode. So we found, okay, the most frequent number of the first group puppy is 5. And the second pictures, the mode is 2. So, well, based on the number, you know, okay, 5 is bigger than 2. So the picture number 1, the puppy is cuter. That's a way to analyze the data. So this is the mode. And that's the statistics. You start to make sense of those data you have. And you can say, well, I don't want to have mode. I can have a mean, right? An average, the average. And, well, you can divide all the number, add them together, and divide by the number. That's the average. And the more data you have, like I just sampled the whole class. I have about 30 samples. Or you can go to sample the whole school. You can have thousands of samples. Or you can go to sample the whole United States, the whole world population. The bigger your sample size, the more normal distribution it's going to look like. And the normal distribution, sometimes you call the Bell distribution or the Gaussian distribution. It look like this. It look like this. So most of us will stand in the center. That's the average. And we're going to have standard deviation. Okay, we're going to talk about standard deviation. And every time you have a population, it give you a mean and the standard deviation. What does the standard deviation mean? Standard deviation tell you 68, 95, 99.7 rule. It tell you about 68% of the sample stay in one standard deviation, like the mean plus 1 minus 1. And 95% of them stay in 2 standard deviation, plus 2 minus 2. And 99.7% stayed within 3 standard deviation. This applies to all the Gaussian distribution. Let's look at the example. Use the example to explain this. Okay, you have 2 baby elephants, and they're cute, and they compare their trunk, right? This trunk can grow to 7 feet, wow, when they turn adult. But they're baby, okay? And the Mike have 75 inches of trunk, and Larry have 65. And the Mike will say, okay, he's very proud of himself. He say, I have a bigger trunk than you do. And Larry look a little bit depressed, say, oh, okay, I have a smaller trunk. And you found the Larry suck his trunk. It's very similar to the human baby suck the finger, comfort them. The elephant do that. And you want to comfort Larry, you want to tell him, no, you have a normal trunk. It's not too small. And how do you really say that? Based on what? Right? And we have to look at the whole population. That's why we need to have a mean and standard deviation. So we found at the baby elephant, the mean is 70 inches of the trunk size. And standard deviation is 8. Okay, then let's look at the data. Let's try to courage Larry up and tell Mike, well, you don't need to be so proud of yourself. Okay, let's take a look. And we found the average is 70. And based on what we learned, standard deviation 8. Okay, what does it mean? It tells you about 68% of the elephants, their trunk stay in 1 plus 1 minus 1 population. Plus 1 or minus 1 standard deviation. So start from 70. If you're 71, you are very normal because you're similar to 68%. You're 74, you're still pretty normal. You're still within this range. You're 75, yeah, don't be so proud of yourself, right? Because you're still in this normal range. 68% people are the same as your size. You go to 76, okay, still within the normal until you go to 78. Okay, maybe you can be a little bit proud of yourself because you are above 1 standard deviation. And that's the standard deviations, the meaning of standard deviation. It tells you, okay, in the whole population, and 68% stand in 1. So if your trunk is 87, okay, now you need to be very proud of yourself because you're actually higher than 2 standard deviation. 70 plus 2 standard deviation, 70 plus 16, 86. Okay, now you're higher than 2 standard deviation. And this 2 standard deviation is 95, right? 68, 95, 99.7. So you can be very proud of yourself. And if you're 100, okay, you're very, very proud of yourself because you're higher than 3 standard deviation, 99.7%. So you're very good. But now let's go to look at Larry as Mike. Well, now you can really tell Mike, well, don't be so proud of yourself. You are still about 68%. And tell Larry, see, you are here, but you are pretty normal. You don't have a smaller trunk. You're pretty normal size. So that's how we use the mean and standard deviation. And here we just briefly talk about it. If you really want to learn statistics, you have to take the statistics class. So let's go back to human. In human, we compare the IQ, okay, IQ test. And after you do the IQ test, your teacher only gives you your number. And you will ask your friend, okay, what's your IQ number? I won't tell anyone else. And he will say, oh, I have 99. And you say, okay, I win, I have 101. Well, should you be proud? No, the answer is no. You are still in a very average size. So in the IQ test, the mean is 100. It's 100. Standard deviation, 15. That means 68% of the people stay between the 85 to 115 range. And this is pretty normal. And if you're over 1 standard deviation and you're in this range, and 95% stay in this range, 70 to 130, and 3 standard deviation is 145. And you found, oh, okay, they talk about the gifted students, they talk about highly gifted students, they're based on this. Gifted, you're higher than 2 standard deviation. So you're top 5% because this is 95. Right? And highly gifted, top than 99.7%. So most of us were pretty normal. We're in this range. Unless you're Einstein. His IQ is over 160. Wow. No wonder he's so smart. So most of us were pretty normal. And that's statistics. Okay, that's it.